In the world of railways, there are three main methods of powering locomotives: steam, diesel, and electricity. Naturally, engineers experimented and combined some of these locomotive types in attempts to produce better and more efficient machines, resulting in semi-successful steam-diesel hybrid locomotives and the current most popular locomotive type, diesel-electric. That leaves us then with the question, what does a steam-electric hybrid look like? The answer is something like this. By the late 1800s, steam was the dominant means of locomotive power on pretty much every railway around the world. However, electricity was slowly becoming more refined, and as such, many railway companies saw the benefits of electrification as something worth pursuing. Electric locomotives could accelerate better and reach higher top speeds than contemporary steam engines, but required a lot of costly infrastructure in order to run. Another advantage electric locomotives had over steam was they didn't produce hammer blow, a force produced by the engine's cylinders that caused the driving wheels to effectively hammer the rails and locomotive, causing damage, especially when travelling at higher speeds. Wanting to try and alleviate the effects of hammer blow, Jean-Jacques Heilmann decided to experiment by giving steam locomotives electric transmission. This having the added benefit of giving the locomotive the same high-speed performance as an electric locomotive while not requiring any of the expensive infrastructure. After settling on using DC motors and generators, Heilmann built a prototype engine with a triple expansion steam engine, a generator capable of providing 360 kilowatts and a tender. The locomotive worked by using steam to generate electricity, which would then directly power the electric motors connected to the locomotive's wheels. Seemingly pleased with the results, he patented the design in 1890 and founded his own company, the Société Industrielle des Moteurs Électriques et Vapeur, intent on building a proper prototype locomotive. Construction of his new project began in 1892, and by 1893 this unique locomotive was complete. Coming in at 16.5 meters long and weighing 100 tons, the engine featured a boiler from French Shipbuilding Company, the New Society of Forges and Shipyard of the Mediterranean, the frames came from the French Railway Equipment Company, the engine came from the Swiss Locomotive and Machine Works, and the electrical equipment came from Braun Bavarian C in Switzerland. The cab was positioned at the front of the engine, with the smoke box and funnel positioned at the rear, making it appear as if it was driving backwards. Water was stored in side tanks and the coal in bunkers at either side of the firebox. The engine was equipped with two cylinders, one high pressure and one low pressure, and would directly power the dynamo. Rated at approximately 500 kilowatts, the dynamo powered the 8 traction motors used to drive the locomotive, with each axle having its own motor. The motors were connected in parallel, and at low speeds the motors could be halved to 2 sets of 4. There was also another, less powerful dynamo which generated electricity for carriage lighting. As well as air brakes, the locomotive was also fitted with disc brakes too, something quite unusual for a railway locomotive of the time. The end result scarcely looked like a steam locomotive at all, and functionally is more comparable to a modern diesel-electric locomotive. Because of its unusual transmission, Heilmann decided to name his engine La Fusée Électrique, this being French for the electric rocket, as a nod to Stephenson's rocket. Testing began in 1894, with Fusée tackling the tricky line from Buzeville-la-Grenière to Le Havre, a route containing a 10-kilometer climb with grades averaging 1 in 125. An average speed of 51.5 kilometers an hour was achieved on the first run, with consecutive trips progressively getting faster. By the fourth trip, Fusée was averaging 59.4 kilometers an hour, achieving 70 kilometers an hour on level rails. A top speed of 107 kilometers an hour was achieved in a later test, and as a result the locomotive was used to pull a regular service to Paris. It wasn't just the engine's speed that was impressive either. It was said to ride as smoothly as a Pullman carriage and used 15% less coal than a conventional locomotive. As such, once the trials were over, the Chemin de Fer de l'Ouest put in an order for 2 of Heilmann's engines to test on their line. Fusée was broken up in 1897, but in its place came numbers 8001 and 8002. These were essentially the same design as their predecessor, but bigger, measuring in at 28.3 meters, the Lentz firebox was swapped out for Belpaire, and the dynamos and engine blocks were replaced with much beefier units. Unlike the prototype, these two were fitted with reversing mechanisms, allowing them to work comfortably in either direction. The first test run was conducted in November 1897 with great success, but with the engine's speed limited to 30 km an hour. The speed restriction was removed for later tests, and the Heilmanns didn't disappoint. One of the engines managed to clock a speed of 100 km an hour while pulling a 250-ton passenger train, with one of them managing to reach 120 km an hour on a later trial. What gave these engines such incredible performance was not only their electric transmission, but also the fact that the weight of the boiler and dynamos rested perfectly on the bogies, greatly improving the locomotive's adhesion. This, combined with their fuel efficiency and smooth quiet running, made them very popular, with railways in Russia, Germany and the US showing interest. However, they still came with drawbacks. Firstly was their weight. As much as the engine and dynamos helped with adhesion, they also added a few extra tons to the locomotive's overall weight, making them much heavier on their wheels than contemporary steam locomotives of a similar size. The extra weight didn't seem to improve their power much either, as from what I've gathered, despite their impressive starting traction, their overall power wasn't as great as that of contemporary steam engines, which leads on to another drawback: unnecessary conversion of energy. In a conventional steam locomotive, the power produced by the boiler is immediately transferred to the cylinders, which then power the engine's wheels. Because of this, most of the locomotive's energy goes directly to the wheels with little being lost. Heilmann's design, however, required the energy from the boiler be converted to electrical energy first before being sent to the motors, where it's then converted back into kinetic energy, resulting in some of that initial power being lost in the conversion process. But the biggest drawback the Heilmanns had was that, for the time, they were too complex to operate and maintain. Operating the engine required a driver, fireman, and an electrician pilot to maintain the electrical components, which meant paying more crew to operate one locomotive. The layout of the engine as well also meant that there was a great big dynamo in between the driver and fireman, making communication between the two significantly more difficult. Because electrical locomotives were still an emerging technology, parts were expensive, and by extension, so was fitting them. Not to mention, you had to essentially maintain a mini power plant on top of the workings of a regular locomotive. Don't get me wrong, the performance and fuel economy for the time was phenomenal, granting railways many of the benefits of electric operations without the need for the infrastructure. But the simple fact that they cost more for less power compared to a standard steam engine was enough of a drawback for railways to lose interest. With enthusiasm for the design, both local and foreign, drying up, Heilmann sold his business in 1898 to Westinghouse and moved on to designing hybrid cars instead. 8001 and 8002 were retired and scrapped not long afterwards. Though all of the engines were scrapped, one Heilmann locomotive technically survives in the form of a 10th scale model of the prototype built by Heilmann himself in 1903, currently on display at the National Conservatory of Arts and Crafts in Paris. Given that most of the criticisms Heilmann's engines faced were later used to criticize diesel-electric engines, it's fair to say he may have been a little ahead of his time with the design. Might the engines have proved to be more popular if they were built at a later time when such electrical equipment was more common? It's not likely, but who can know for sure? All we do know is that they're another example of an invention being a little too ahead of their time. Subscribe for more.